Hey, welcome! Today, we're going to dive into something that's literally at the heart of all our gadgets, resistance, and the tiny little components that manage it, resistors. Yeah, we're journeying into the hidden world that, believe it or not, powers pretty much everything you use.
I mean, have you ever really stopped to think about that device in your hand? How does your phone, or your laptop, or really any gadget make sure it gets just the right sip of electricity? Not too much, not too little, to work perfectly without, completely frying its own circuits. Well, the answer is a simple and honestly a pretty brilliant principle.
Okay, so before we get to the how, let's talk about the why. Why is it so absolutely critical to control the flow of electricity in a circuit in the first place?
Think about it like water flowing through a pipe. If you just open the floodgates, right, that powerful gush of water can smash everything downstream. It's the exact same idea with electronics. An uncontrolled surge of electrical current can instantly destroy super-sensitive parts, like processors or tiny LEDs. So for any device to work safely and reliably, we have to have a way to tame that flow.
And that leads us right to the core physical property that makes all of this control possible: resistance. So, what on earth is it, and where does it even come from?
Let's zoom way in, down to the microscopic level. Inside any metal wire, like a copper wire, there are just countless free-floating electrons, kind of hanging out, waiting for a push. And when we apply a voltage, say from a battery, that gives them the push they need. They start moving, and boom, you've got what we call an electric current.
But here's the catch. Their journey is anything but smooth. It's kind of like trying to run through a really crowded hallway. As these electrons are being pushed forward, they don't just zip along in a nice straight line. No way. They are constantly bumping into and colliding with the atoms, the positive ions, that make up the wire itself. And every single one of those collisions slows them down and gets in their way.
And that whole phenomenon, all that microscopic bumper cars, that opposition to the flow, that's what we call resistance. It's a totally natural property of a material that acts like a brake on the current. So here's the key takeaway. Resistance isn't some problem we're fighting against. It's a fundamental tool that we've learned how to use.
Now, not all materials are created equal when it comes to this. Some, like copper, have a really clear hallway, so they have very low resistance. That makes them perfect for wires, right? We want current to flow easily. But what happens when we actually need more resistance?
I mean, if the wire itself doesn't have enough natural resistance for what we need, how do we add more? Well, this is where a very specific, carefully engineered component comes into play: the resistor.
So let's say you've got a sensitive little component that needs just a tiny trickle of current to work. But the copper wire you're using, it barely slows the current down at all. You can't just make the wire miles long. That's not practical. There's got to be a better way.
And of course there is. We use a resistor. It's an electrical component built